Imagine you are at the top of a 50-story building. You have that special person there with you, you're looking out over the city, the sun is setting, you have a glass of champagne, everything's good, life is perfect, just enjoying the moment. And then all of a sudden, you feel a tremor under your feet, and you see the building is starting to shake. Glasses are breaking, lights are swinging around, people falling, screaming, shouting, trying to hold on to one another, and you realize this is an earthquake. And above all, you are 150 meters up in the air. Just when you think things cannot get any worse, you hear concrete breaking, and the building is starting to lean. Now, my research can prevent this entire scenario from ever happening by improving the mathematical models used to build tall buildings. During an earthquake, buildings undergo whiplash kind of motion. That means the building is swaying in one direction and then whips to that side, swaying in the other direction and whips to that side. You can think of when you're in your friend's car and they all of a sudden put their foot flat on the pedal and you're pushed back into your seat. That is exactly what it would feel like to be at the top of that building. Except there's no car seat there to catch you and the building is going in all directions. And it is exactly those rapid motions of the building that causes damage to the structure, which can even lead to collapse, but also damage to the internal components, which sometimes costs even more than to construct the building. But you also have these tables, cabinets falling over, everything moving around with people on the inside. So it very quickly becomes a very dangerous environment. Now, by improving the mathematical models used to construct these buildings, the buildings are able to better resist that rapid motion. So the whiplash effect is less, the damage to the structure is less, the internal components are safer, but most importantly, the people on the inside are much safer. Now, to those of you who think that this problem might not be relevant to South Africa at the moment, I want to let you in on a little secret. If you have a massive wind load or a wind force on a building, it can have exactly the same effect on that building as if an earthquake would hit it. So, why do you think Burj Khalifa was not built in Cape Town? I want to call all emerging researchers to my field of research because your research might be very relevant to the South African context in the near future. Thank you.